Well, hello, Y11. Welcome to your video or feedback video session for the homework, page 123 to 127. Same rule as always. Get your green pen. Give yourself a mark if you got the right answer. Write down the correct answer in green if you got it wrong or if you didn't answer it. Let's do it in less than 15 minutes. Starting now. Let's go. I'll attack. Some elements and compounds consist of molecules that are held together by covalent bonds. Describe how two atoms come together to form a single covalent bond. Each atom is going to share one of its electrons with the other atom in order to share a pair of electrons. And this pair of electrons is the covalent bond. What type of elements are able to form covalent bonds? Non-metals. Okay, so non-metals together are going to form covalent bonds. They're just missing a few electrons on the outer shell, so they're going to share it. Boron is a compound that contains covalent bonds. Use the diagram below to find the molecular formula of boron. So it's made of one B, one boron, and 3 hydrogen. So the formula is BH3. The diagram below show dot and cross diagrams of some simple covalent molecules. Draw out the displayed formula of this molecule using straight lines to represent covalent bonds. Hydrogen has been done for us. So the second one is called methane. It has one carbon with single covalent bond with 4 hydrogen. So we're going to draw it like this. The third one, is water, H2O. And again, oxygen is going to form a covalent bond with each atom of hydrogen. So you draw it like this. If you look at the molecule of oxygen at the bottom, you can see 2 crosses and 2 dots. That means there is 2 pairs of electrons. It's a double bond. So you're going to draw 2 horizontal lines between the atom of oxygen. Methane, CH4, is a covalent molecule. The structure of methane can be shown in a number of different ways. 2 such diagrams are shown in figure 1 and 2. So the first one is a dot and cross, and the figure 2 is called the displayed formula. Suggest 2 different ways of telling, either from 1 and 2 or from the molecular formula, that methane is a covalent molecule, where you can see that there is a shared pair of electrons between carbon and each atom of hydrogen. And also C and H, or carbon and hydrogen, are both non-metals, forming covalent bonds. State 2 ways in which figure 1 and 2 do not represent a methane molecule accurately. It doesn't show the 3D structure, it doesn't show how atoms are arranged in space, and it doesn't show the size of atoms. Briefly describe how the hydrogen atoms in the methane molecule are bonded to the carbon atom. So each atom of hydrogen is going to share its electron with an atom of carbon, which in turn is going to share one of its electrons. So they form a shared pair of electrons. These electrons are attracted to the nuclei of carbon and hydrogen. So remember, the nuclei are positively charged, the electrons are negatively charged. So each nucleus is attracted to the pair of electrons holding the molecule together. Pretty cool. Next one, number 4. The structure of a covalent compound can be represented in many different ways. Give one advantage and one disadvantage of using each of the representation of covalent molecule described below. So the displayed formula, you're going to represent each bond by a straight line between the atoms. Okay, so it shows how all the atoms in a compound are connected in a simple way, but it does not show the 3D arrangement of the size of the atom. The dot and cross, he shows where the electrons of a covalent bond originally come from, but again, does not show the 3D structure of the molecule. And the 3D model shows how all the atoms are arranged with each other, but it is becoming complicated for larger molecules. It's really hard to draw the 3D model for a molecule that has even 5 atoms start being complicated. Suggest with reasoning which of the representation in 4.1 would be most suitable for drawing the structure of a large polymer in order to show what each atom is connected to. The displayed formula would probably be the best, as it's easy to see how the atoms in a large molecule are connected without a diagram becoming too complicated. So you're going to draw a single line to show the covalent bond between the atoms. That's the displayed formula. Simple molecular substances. This question is about the forces in simple molecular substances. So remember, the molecules are made by non-metals bonded together. Compare the strengths of the bonds that hold the atoms in a molecule together with the forces that exist between different molecules. So inside the molecule, we have very strong covalent bonds. Okay, So those are really strong. But the forces of attraction between the molecules are very weak, which is why when you boil or change the state of a simple molecular substance, it's pretty easy because you have to break down this very weak force of attraction between molecules. When a simple molecular substance melts, is it the bonds between atoms or the forces between molecules that are broken? It is the forces between the molecules, called intermolecular forces, because they are the weakest and they're really easy to break. So you just provide a tiny bit of energy, they break. Next one, HCl and N2 are both simple molecular substances. Draw a dot and cross diagram to show the bonding in the molecule of HCl. Show all of the outer shell electrons and use different symbols for electrons from different atoms. There is no need to show inner shell electron. So hydrogen has one electron in its outer shell, can have a maximum of two. Chlorine belongs to group 7, so it has 7 electrons in its outer shell and needs an extra one. So we're going to have this overlap with one cross coming from chlorine and one dot coming from hydrogen. If you look now, chlorine has 8 electrons in its outer shell, it's happy. Hydrogen has 2, which is the maximum you can do in a first shell, it's happy. Ta-da, HCl. Draw a dot and cross diagram to show the bonding in the molecule of nitrogen, N2. So nitrogen belongs to group 5, 5 electrons in its outer shell, it needs 3 more. Therefore, each atom of nitrogen is going to share 3 electrons with the other atom of nitrogen. Okay, and if you look, we have 3 pairs of electron in between, in the middle, so 3 crosses and 3 dots. Make sure when you draw that you have in total 5 crosses and 5 dots, the original electrons from each atom of nitrogen. State one difference between the bonding in HCl compared to N2. You can say that HCl has a single covalent bond, only one shared pair of electrons. Nitrogen has a triple bond, 3 shared pair of electrons. That's a difference. The bonding in N2 is a lot stronger than the bonding in HCl. Iodine is a simple molecular substance, formula is I2. At room temperature, iodine is a solid. Explain with reference to the forces between molecules why this is unusual for a simple molecular substance. So simple molecular substances have weak intermolecular forces of attraction, so little energy is needed to overcome them. But obviously, the stronger these forces of attraction, the higher the melting point. And iodine is strong enough, or the intermolecular forces are strong enough to stay solid at room temperature. But you don't have to heat it up that much to turn it into a liquid and a gas. Predict with reasoning whether iodine can conduct electricity in any state. Well, if you look at the molecule, there is no ions that can carry a charge, so probably not. And there's also no delocalized electron. So iodine cannot carry a charge, is not a good conductor of electricity. Next, both methane CH4 and butane C4H10 are simple covalent compounds that are gases at room temperature. Fact. Methane has a lower boiling point than butane. Explain in terms of particles what happens when methane boils and why the boiling point of methane is lower than that of butane. So, when methane boils, the intermolecular forces of attraction between molecules of methane are overcome and it turns from a liquid to a gas. Methane is a lot smaller than butane, so the intermolecular forces are weaker in between molecules of methane than they are between molecules of butane. Less energy is required to overcome them. Okay, the bigger the molecule, the stronger the attraction between molecules, the higher the melting and boiling point. Explain why a carbon atom can form up to 4 covalent bonds, whilst the hydrogen atom only ever form 1 covalent bond. So atom has 4 electrons in its outer shell. It wants 4 more, so it's going to form 4 covalent bonds. Okay. Hydrogen only has 1 electron, but it's in the first shell that can only contain 2 electrons. So it only needs 1 extra electron, and therefore will only form 1 covalent bond. Suggest how many covalent bonds an atom of silicon would form. Explain your answer. So silicon belongs to group 4. Therefore, it also has 4 electrons in its outer shell. So it needs 4 more electrons to have a full outer shell. So it will form 4 covalent bonds, just like carbon. Polymers and giant covalent substances. Circle the diagram below that represents a compound with a giant covalent structure. So it is the first one. The second one here, the CH2CHCl with a little n, that's how you represent a polymer. The third one is a molecule made of 1 atom of an element and 3 atoms of another element. And the last one is an ionic compound. We know that because there are charges represented in each of the sphere. Graphite and diamond are compounds with very high melting point. Oh, by the way, the first one here, that's diamond. Each atom here is carbon. Graphite and diamond are compounds with very high melting point. Which of the following compound is not an example of a giant covalent structure? Ammonia is the answer. Okay, ammonia is NH3. It's probably the one represented here on the third one. Simple molecular structure. Diamond is made of a million of atoms of carbon, all bonded together, represented here. Graphite is also made of a lot of atoms of carbon. It's a slightly different shape than diamond, but it's still a giant covalent lattice. And silicon dioxide, SiO2, is also a giant covalent lattice. You need to know those one: diamond, graphite, silicon dioxide, and graphene are the giant covalent structure you need to know. To melt a giant covalent compound, the covalent bond between atoms must be broken. Explain why this causes giant covalent compounds to a very high melting point. The covalent bonds are really strong, so they require a lot of energy to overcome. Therefore, the melting point of the giant covalent lattice is extremely high, one of the highest in the world. Okay, figure 1 below represents a large molecule known as a polymer. Okay, so the CH2 like this is called a monomer, and this unit is going to be repeated over and over again. What is the molecular formula of this polymer? So again, you can write it down as C2H4 bracket and a lowercase n to show that this unit is repeated many times. Is this molecule likely to be a solid, liquid, or a gas at room temperature? Because it's a huge molecule, remember we said that the bigger the molecule, the stronger the force between the molecule. Because this is huge, you can have very strong intermolecular forces of attraction, very hard or requiring a lot of energy to break. So it's probably going to be a solid. Okay, so this is all the point you need to make to get 3 marks. It's going to be a solid because the molecule is very large. There are very strong intermolecular forces of attraction, lots of energy required to overcome them. State what type of bond hold the atoms in the polymer together. They're all represented with a single line, which means those are covalent bonds. And this is it for today's video. Hope you enjoyed it. Make sure you have all your answer written down in green pen. Make sure you bring your work back into class. Stay amazing. Good luck with all your revision. Bye bye, guys.